morning. You have 4 tasks that you need to accomplish today. We'll go over them one by one, starting with number 1. My name is Michelle Mullen. I teach at Twin Peaks Middle School in San Diego, California. This is a 7th and 8th grade combined pre-algebra class. You need to calculate the surface area and volume for 1 to 10 rods. Now, let me show you what I mean by that. This is 1 rod. And you are not necessarily going to have a green rod. You could have any color. I'm going to give every group a different color. So starting with 1 rod, I'd like you to calculate the surface area and volume of this rod. Then what we're going to do is you're going to put another rod right next to this first one so that you are covering up this edge. So now you have a new shape, this bigger shape, that you have to calculate surface area and volume of. And then we'll do the same thing again for 3 rods, and then 4 rods, and so on and so forth, going all the way up to 10 rods. After you've finished with this first task, every group has to do this one first, then you can do any of these 3 in any order that you would like to. So let's go over these other 3 tasks. The second one says that you need to generate a formula for n rods. And this formula has to work for all 1 through 10 and anything greater than 10 also. Then number 3, you need to graph your data. You're going to come grab a piece of graph paper. And I have markers out, I have rulers out. And this is just 1 per group. Not every person has to do this. And then the last thing that you need to do, you need to come up with a question to explain this problem to next year's class. Now, the way I just presented this to you was not in a question form. But you need to, in your groups, come up with a way to phrase this problem in a question so that if I gave this to another class, they would know exactly what to do. Okay, is there any questions on this number 4 here? No? Okay. Then what I'm going to do is I'm going to give each group their rods, and then you guys can go ahead and get started.
31, 32, 33, 34. It's 34 on 2 of them.
Yeah, that's what I said.
30 though?
Okay.
10, 20, 30.
No. That's 5,
5, 10, 15.
Every group had a different length rod, and as we increased the number of rods, I wanted them to see that there was a pattern instead of actually going through all 10 of the rods. And I'm hoping that they will get out of it that this is a linear relationship. If we increase the number of rods, the surface area and volume increase linearly. The last chapter we just finished was on linear graphing, and the unit before that was on surface area and volume. So these 3 days, I'm hoping, will tie everything together.
Okay, now we have to do volume. Base times height, length times width. Let's see, first surface area would be surface area equals
12, or whatever the answer is.
So we have
The answer before it plus 12.
Yeah.
So how would you write that?
Preceding answer plus 4, or 12.
You have to write it. You can't put preceding answer. It has to be a number or a letter.
Well, let's just go into volume for right now.
Okay.
We can figure that one out easier. So
That's
that
base
just means
times height.
Times 5.
5 times
N times 5.
n times 5.
For any figure, what if the thing
Yeah.
has 10 sides? Is it still 5
Or
times?
you add
No,
5.
it's for this one.
Then you add 5.
3, 6, 9, 12, 14. The surface area? For 1. For 1.
Well, I really knew how to do surface area and volume, but we all helped together to find the formula for n. We thought because there were 6 sides to the rod, then we had to somehow times n by 6, and we just experimented with different numbers, and we finally got our answer, and it was right, and we graphed it.
I think it's n equals n times 10, right? Like what you first had.
Why would it? No.
No?
Because 18 times 10 is 36.
Okay,
It's like n
10,
plus...
n times what?
It's n plus 10.
N plus n?
10. Because
Oh,
18
okay,
plus
it's n
10
plus
is 28.
10. Yeah, okay, so n equals n plus 10.
Yeah.
Okay, so that was all right. we have to graph our data now. So I was thinking,
Look, this is what I was thinking. N to the power of 8 times 10 equals
n to the power times 8.
of 8 equals times 10 equals n. So that way it's like everybody knows that one block equals 8.
Equals 18.
Yeah, equals 18.
So it'd be 18.
Yeah,
So n equals n times the power of 18.
18 times 10. Well, let's do a rough draft on here and then we can get a big piece of paper and then we can write a big graph.
Okay. So how should we do it? Should we do it by fives? Because I don't think we'll have enough room then anyways. Yeah. Do it by fives or do it by tens? 10 sounds better.
10.
10.
10.
Okay.
Are we supposed to do like an x and y axis graph, or are we just
Yeah,
like,
x and y axis. We do all of them. So it's x and y axis.
plus 4? Just work for the last two. Look, it's work for this one and this one.
Okay, you guys need to explain to me what you're doing so I know.
Well, we divided the number, like the number cubed, like 10 cubed, by the surface area, and we got, it was either 6.4 or 6.4 bar.
Okay.
So it was in the sixes, and then we decided to do 6 times 10 would be 64, and it was always 4 off.
Oh, so
Yeah,
6 times 4. Oh.
And we had to do 6 because it was adding 6 every time.
Yeah.
Okay,
So we
so
just decided to multiply
how
by
can you write that with n then instead of 6
times n plus 4.
Okay, so let's write that in a formula form. Show me what that would look like. Okay, now.
It'd be inside the parentheses, wouldn't it? It'd be 6
N plus 4.
and plus 4.
Okay, well now what I want you to do is to check this formula with 1 or 2 or 3 of these numbers to see if that works.
We just check in with this one. See,
Okay,
it'll
check
be
it.
10 times 6.
Wait. That's not what you wrote. Parentheses first, order of operations.
Oh yeah, then you have to do it.
Okay.
It'd be plus 4, so it'd be 10 times 6 equals 60 plus 4, 64.
Okay, so we know it works for 10. Let's check another number.
9 times 6 equals 54 plus 4 equals 58.
Did it work?
Yeah, well,
So you think you have a formula?
yeah.
Okay, so 58. 68.
Students were really comfortable with the graphing because we graph everything in this classroom. And we graph on big chart paper a lot. We graph on small graph paper all the time. Sometimes they have to generate their own graphs. I want them to know what it looks like.
208?
Yep.
Yeah, 202.
How would you find surface area of this one rod?
There's 10 on each side, so you have to go 10 times 4, and then there's 2 at the ends, so you have to do plus 2.
Okay, good. Now, instead of a 10, let's do an n. How would you write that using n, that same formula that you just said?
N times 4 plus 2.
Okay, so Tiffany, did you get that? Understood where she came from? Okay, Alex?
Yeah.
Okay, so now let's do the same thing, but instead of one rod, we're going to do 2 rods. How would you find the surface area?
N times 4 times 10.
See, does that work? Try it, see if it works.
Plus 4, because there's 2 on each side now.
Okay, but look, is this side the same as this one now? Oh.
Be n times 2
Plus
20
Which is n times?
10.
You're there, Tiffany, though. For a couple of the groups, volume was much easier, but for surface area, I would ask them, how did you find the surface area of this one rod? And they would tell me, we took the length multiplied by 4 to get all 4 sides and added the 2 ends. Now let's add another rod. How would you do that? And then that got them started thinking about how could you generalize that into a formula. How is your formula changing from 1 rod to 2 rods to 3 rods? It changed a little bit. Plus,
Because, like, for 1 rod, there's 2 ends. with like 1, and then for 2 rods there's 2 at the end, and then for 3 rods there's 3 at the end.
So what do we keep adding every time?
1. Or 2.
2 more. So we know we're going to have a plus 2 somewhere in our formula.
Okay.
Okay? So what about what we're multiplying? We say we multiply by one number, and then we change it to a different number, and then to a different number.
You add 3 onto that. And it's 3 more sides for each one.
Okay, so what I need you guys to do now, I'm not going to give you the answer. Okay, what I need you guys to do is to experiment with what all 3 of you have just said. Okay, starting with 1, then going to 2, and then going to 3, and so on and so forth. And you can even go to 4 and see if you can come up with the surface area formula.
Okay.
Okay? Good job.
Color it orange. Orange is better. When you make a graph, it helps you to understand it more because it really simplifies it. You don't have all this big jumble of numbers that you have to figure out what they all mean while you're trying to move on. And so people made different kinds of graphs. And for our graph, we chose to make a bar graph. In one column, we put the number of rods, and then on the other column, we put what the surface area and volume actually was. What number? 5 is 70, yeah. And the next one is 82.
Tomorrow, I'm going to have each group present what they've come up with, all of the new ideas. And then we are going to mark items that absolutely have to be included into the problem. Then somehow, together, we need to come up with a way of phrasing this question so that if I present this to another class, they will know what to do. And I'm actually going to present it to another class and see if they, in fact, know what to do.
From what you have just seen, what do you know about these students' mathematical power? How can you help students learn to generalize patterns into formulas? What are the components of a good task?